talk about ions now. So please have your periodic table out. Um, and we're gonna see, how it works when an element either lose or gain electrons. Okay, that's how they become ions, right? And there are two types of ions, okay? Positively charged ions are called cations, and negatively charged ions are called anions. Okay, so you should know those terminology. Okay. So atoms like to lose or gain electrons. A lot of atoms are reactive, so they don't just want to stay neutral. They either gain or lose electrons. And remember that electrons are negatively charged, right? So if you lose electrons, you lose a negative charge, and therefore you have a surplus of positive charge, meaning you become a cation. Okay. So when you lose electrons, you become positive. All right. Now, when you gain electrons, of course, since electrons are negative, right? If you gain a negative, you become negative, right? So you become an anion when electrons are being gained. Okay. The way I like to think about it, it's like life, right? If you lose negative things in your life, you become more positive, right? But if you gain negative things in your life, you become more negative, right? Okay, so let's talk about the periodic law and the periodic table. Yep, so please have your periodic table out. The way that it's arranged was in 1869, Mendeleev noticed that there were certain group of elements that had similar properties. And so he listed the elements. He found that when he listed the elements in order of increasing mass, these properties recurred in a periodic pattern. So that's why it's called the periodic table. So there's this repeating pattern where certain elements would behave similarly, right? Will have similar physical and chemical properties. So, here's an example, right? He would list from hydrogen to calcium, and he saw that, oh, lithium, sodium, and potassium, for example, have similar properties. So instead of the periodic table being like just long, right, horizontally, where he saw that they had recurring properties, he started a new line. So that's why lithium, sodium, and potassium now are in the same column, right? And so that's what we know now, is that elements that are in the same column will have similar chemical and physical properties. Okay. And that's going to be really helpful later on when you guys are like, trying to predict reactions, trying to predict what an element will do, right? Will it gain or lose electrons? It's really useful to look at the column, with respect to the noble gases. Okay, so keep that in mind. Similar properties fall into the same columns. So Mendeleev's table actually contained some gaps at the time, right? Because they didn't know all the elements. They just had, the existing ones. But he was so keen on his observations that he was able to predict undiscovered elements, right? He was able to predict their density. He was able to predict, how they react with oxygen, their melting points and boiling points. He was pretty good at predicting those. So, for example, he predicted the element which he called ecosilicon, which was later, named germanium when it was actually found by the German chemist Winkler. And germanium had the properties that Mendeleev predicted. So pretty remarkable. Um, Mendeleev just using the periodic law to predict, undiscovered elements. So now in the modern periodic table that you guys look at, elements are listed in order of increasing the atomic number rather than increasing mass. It just works better that way. But it still looks very similar to Mendeleev's table. So he's, credited with, how your periodic table looks right now, right? And so when you pick up a periodic table, they all look something like this, right? And you can divide the big periodic table into these major three divisions. The metals, which are on the left side of the periodic table, right? Left lower side of the periodic table, in sort of in yellow here. And then in the green, that's the upper right, that's the nonmetals. Okay. And then you have these elements that border the metals and the nonmetals. They're called metalloids, meaning they're like metals, right? But they're not actually metals. So they take on properties between the metals and the nonmetals, right? So on your periodic table, if you want, you're not allowed to write anything on it, but you can color code, right? So if you want to color code, you want to draw this staircase a little bit stronger because you see the metalloids are the ones that are bordering this staircase, right? So that, you can have like a rough division of the periodic table as well, okay? Okay, so the rough classification, right? Metals, nonmetals, and metalloids. Let's go into more details about each of these division. So the metals are on the lower left side, and they all share some common properties. They're really good conductors of heat and electricity. They're malleable, which means they can, bend and be pounded into flat sheets. They're ductile, which means they can be drawn into wires. They're often shiny, right? We know that. And when they undergo chemical reaction, they tend to lose electrons. Okay, so meaning they tend to become cations, aka positive, right? So chromium, copper, strontium, lead, right, are typical metals. You guys have heard of those, right? Very, very shiny, malleable, ductile, right? And tend to lose electrons. Nonmetals, on the other hand, right, they are opposite of metals. They lie on the upper right side of the periodic table. There are a total of 17 nonmetals, right? 5 are solids at room temperature. So carbon, phosphorus, sulfur, selenium, and iodine are solids. Only 1 is a liquid, and that's bromine. And then 11 are gases at room temperature, right? So we know that the noble gas, right? Helium, neon, krypton, xenon, all the noble gases, and then also hydrogen, nitrogen, oxygen, fluorine, chlorine, um, uh, and then radon. Radon's a noble gas as well, right? So 11, 17 total, right? So you can say that on the periodic table, you have mainly metals, right? And also state of matter wise, mainly solids, right? At room temperature. So their properties tend to be opposite of metals, right? Poor conductors of heat and electricity, not ductile, not malleable, and they like to gain electrons when they undergo chemical changes, right? So that means they want to become negative, right? So gain electrons, become negative. So oxygen, carbon, sulfur, bromine, iodine, all those are considered nonmetals. All right, and then the metalloids, right? Those elements that are lying on that staircase or that zigzag, okay, they exhibit mixed properties, properties between those of metals and nonmetals, right? And so they are often classified as what we call semiconductors because of their intermediate electrical conductivity. Okay, so the periodic table can also be divided into the main group elements and the transition elements, okay? So you should know this division as well because I will be referring to that, right? Main group elements versus the transition elements or the transition metals. So where are those? The main group elements are on I call them the wings of the periodic table, right? So on the first 2 columns, and the last 6 columns are the main group elements, okay? And then in the middle, we call those the transition elements, okay? And there's something else you should notice, how they are numbered. So if we count, okay, you see these little numbers, 1, 2, right, 3, 4, 5, 6. We count all the way across, we have 18 columns on the periodic table, okay? And then we have 1, 2, 3, 4, 5, 6, 7. Okay. And that's 7 rows. Okay. And there are terminologies for these. The columns are called groups and the rows are called periods. Okay. So if I'm referring to period 3, then I'm talking about this row right here that starts with sodium. Okay. Now for the columns, you see that there are, two ways of numbering, right? You have just 1 through 18, but you also have the A's and the B's. The A's and the B's separate the main group, right? The main group get A behind the number, and then the transition elements get B. So that's the numbering I'm going to use, right? I'm going to be like group 6A. Group 6A is column 6A, okay? And that's the column that starts with oxygen, okay? Or if I say group 2A, then I mean the second column, right? That starts with beryllium, okay? So for main group elements, that's how I will refer to them, okay? So you should be used to, how I refer to these, right? How to number these. And so again, if I say period 5, now that means row, right? Period 5 starts with rubidium here, Rb, and goes all the way across. Right? All right. So, right, vertical column is group, horizontal row, period. There are a total of 18 groups and 7 periods. Okay, let's start with the noble gases. Okay, so some of these columns, since we know a lot about them, some of these columns, some of these groups get a name to them, right? So group 8A, that's the last column on your periodic table. Those are called the noble gases. Okay, and why are they called noble gases? Noble means they are unreactive. Okay? They're very stable, and they don't react. Okay, so things like helium, that's used in balloons, right? Very chemically stable. It does not combine with any other element. Okay, so you will still find helium in the atmosphere. Um, of course, helium's really light, so it's constantly being lost to space, but there's still some helium left in the atmosphere. And you'd find it in its elemental form because it's so stable, which is really rare, right? To find elements still in their elemental form, as old as we are, right? As old as the Earth is now. Okay, group 1A, you guys should know that this is called the alkali metals. Okay, and the alkali metals are all really reactive metals. Um, they like to react with water. And the reaction with water is really, really vigorous. Okay? Let me show you guys a cool video involving the reactivity of the alkaline metals in water.
Oh, hey. Yeah.
In air, the elements quickly become coated with compounds that form on the metal surface. Here, for example, is lithium. When we splice it, you can see the metallic luster, but the black coating quickly reappears. Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go down the group, the elements seem to react more quickly with air. Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a live flame. The next element is rubidium. This time, we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our fifth alkali metal.
But of course, it's not just the air that they could react.
All right. So you guys can see that the group 1, right, alkali metals are very reactive, particularly with air and water, right? So what happens to them is they get oxidized, which means they lose their one electron. Remember, metals like to lose electrons. So they like to lose their electrons to water, for example, and that creates hydrogen gas, which is very explosive, right? And as you go down the group and the atoms get bigger, later on you guys will know why that is, okay? But as they get bigger, they lose electrons more readily. And so that's what gives rise to the increase in activity of these alkaline metals, right? Okay, and then you guys should know group 2A is called the alkaline earth metals. Their reactivity is very similar to group 1A, but it's not as vigorous, okay? It's not as vigorous as the group 1A. And the reason is group 2A metals, they like to lose 2 electrons. Okay, and so in losing 2 electrons, they're slower at, losing electrons. They have to lose 2. And so the reaction is not as vigorous as in group 1A. Okay, now let's take a look at the halogens, right? So the halogens, group 7A, right next to the noble gases, right? These are actually all nonmetals. Okay, so fluorine, bromine, iodine, and astatine. Fluorine is a pale yellow gas. Chlorine, a greenish yellow gas. That's really pungent. So if you've been in a swimming pool that's treated with chlorine, you can smell that, right? Bromine is a liquid, and iodine is a purple solid. So even though they're nonmetals, the halogens are quite varied, right, in as far as states of matter. Yeah. All right, so let's think about how ions form in the main group. So remember, we said metals, they tend to lose electrons to form cations, right, to form positive charges. Then the nonmetals, they tend to gain electrons, right? And since electrons are negative, you will form a negative charge. You form an anion, okay? And how you can tell how many electrons get lost or gain is to look at your periodic table and see, where the element is with respect to the noble gas. Okay, remember that we said the noble gas is very stable. And so everything, all reactions that happen, they try to get to the noble gas number of electrons, the noble gas electron configuration. Okay, so everybody tries to be like the noble gas because that's stable, right? So if you look at group 1A, okay, go ahead and look at group 1A in your periodic table. That's the first column. Okay, if you ask yourself, what is the easiest or quickest way to get to the noble gas? You have to go left, right? Because the noble gas is um, uh, 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 the last column, right? So you have to go left, and therefore losing 1 electron, right? So remember how the periodic table is set up. It increases by 1 proton as you go to the right and down, okay? So that means if you go back left 1 space, you're losing 1 electron, and therefore you become 1 plus, okay? So group 1A are 1 plus ions. How about group 2A then? right? So put your finger on the column, group 2A, and count the quickest way to the noble gas. You'll see that you want to go left again, right? You want to go left how many spaces? 2 to get to the noble gas. So that means you're losing 2 electrons, and group 2A will tend to form 2+ ions. Okay, does that make sense? All right. Now, let's go to the right side of the periodic table, right? So the halogens. Group 7A is right next to the noble gas, right? And just one space to the right is the noble gas. So group 7A is going to want to go right, right? Going right, one space means gaining 1 electron, and so therefore you form a 1- ion. Okay. How about group 6A? Right? Put your finger on that. Group 6A, quickest way to the noble gas is right, 2 spaces. All right, so that's gaining 2 electrons, and therefore you will form 2- ions. Okay. So for the main group elements, you have pretty predictable charges, as you can see, right? All group 1A elements would tend to form 1+, group 2A 2+, group 7A 1-, group 6A 2-, right? But the transition elements, they form various different ions and charges. So we can't predict those, but here's the table in which, here's the ones that are shown are predictable. So you see that group 1A, 1+, group 2A, 2+, group 7A, 1-, group 6A, 2-, and even nitrogen, right? You can guess what charge it would be. Because it's in group 5A, well, it wants to go 3 spaces to the right, right? 1, 2, 3 to get to the noble gas, which means it wants to gain 3 electrons and therefore becomes 3-. Okay. Now, if you look at aluminum, right, and you ask the same question, what's the quickest way to the noble gas? Well, if you go right, you have to go right 5 spaces, don't you? 1, 2, 3, 4, 5. But if you go left, 1, 2, 3, that's shorter. So that's why aluminum will have the 3+, right? Because aluminum will want to lose 3 electrons, right? So this is really useful, guys. Okay, these predictable charges, you should, that's how you should use your periodic table. That way you don't have to memorize these charges, right? You're going to do it by the position of these elements on the periodic table, and it's going to help you tremendously, later on when you are, forming chemical equations, chemical compounds, when you're doing reactions. It's going to be very helpful. Okay, so that's really how you use your periodic table. This is, one of the key things that you should be able to glean from your periodic table is the charge. All right. So let's do these problems. We just did aluminum, right? We just said the charge of aluminum would be 3+, right? So it wants us to predict the charge of these. So what about sulfur? Okay, I'll give you guys a second. Go ahead and look on your periodic table. So you see that sulfur is in group 6A, right? So group 6A is 2 spaces away from the noble gas, okay? And so it's going to want to gain, right? Because sulfur is to the left of the noble gas. So it's going to want to go right to get to the noble gas, 2 spaces. So you gain two electrons and therefore become 2-, all right? Okay, let's predict the charges for D. Let's keep going. Nitrogen, right? Okay, put your finger on nitrogen, look up at the group number. Okay, you'll see that it's 5A. Okay, so group 5A, you want to go to group 8A. That's 3 spaces to the right, which means gaining 3 electrons, and therefore nitrogen is 3-. Okay, all right, now look at rubidium. Okay, rubidium is in group 1A. Okay, quickest way to the noble gas is going left. You're going to go left 1 space. Okay, and so therefore it's going to be 1+. Okay, that means losing 1 electron is 1+.